Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Aaqib Academy of Mathematics. In previous video, Newton-Raphson method to solve non-linear equation fx was discussed. I discussed the algorithm to solve Newton-Raphson method. Also, a question was taken to discuss the steps. Now, I am taking a new video for you, which is secant method. First, we derive the secant method using Newton-Raphson method. As we know that Newton-Raphson formula is xn plus 1 is equals to xn minus function at xn divided by derivative of function at xn, where derivative of xn is not equal to 0 and n is equals to 0, 1, 2 up to so on. Now to derive a secant formula, we put f prime of xn is equals to function at xn minus function at xn minus 1 divided by xn minus xn minus 1. Now putting this value of derivative of function in Newton-Raphson formula, we get xn plus 1 equals to xn minus fxn into xn minus 1 divided by function at xn minus function at xn minus 1. On simplifying this, xn plus 1 is equals to xn into f of xn minus fxn minus 1 minus fxn into xn minus 1 divided by f at xn minus f at xn minus 1. Now we have f of xn function at xn. These two are cancelled out and we have the final expression for secant method xn minus 1 function at xn, this one, minus xn function at xn minus 1 divided by function at xn minus function at xn minus 1. This is called secant formula for the solution of non-linear equation. Next, we discuss the algorithm for secant method. Now, to find the real root of non-linear equation using secant formula, following steps are carried out. Step number 1, determine the interval on which the function has opposite signs. Step number 2, set the convergence parameter epsilon. Step number 3, select x0 and x1 in the interval by own choice. Using secant formula, which is xn plus 1 is equals to xn minus 1 function at xn minus function of xn minus 1 divided by function at xn minus function at xn minus 1. Step number 5. If modulus of function at xn plus 1 is less than convergence parameter epsilon, then xn is the root of the nonlinear equation. Step number 6. If modulus of function at xn plus 1 is greater than convergence parameter epsilon, then go back to step 3. Now we take a nonlinear equation to solve by using secant method. We have a question: f of x is equals to x cubed minus 5x plus 3 is equals to 0. Now we will solve this nonlinear equation using secant method. Now, step 1. Step 1 says determine the interval on which the function has opposite signs. First we have function at x is equals to x cubed minus 5x plus 3. We take first point 0. Putting 0 in given equation, we get the answer is equals to 3, which is greater than 0. Now put 1 in equation, a given equation, we get 1 cube minus 5 into 1 plus 3, which gives us answer minus 1, which is less than 0. Now we have the interval 0 and 1, so the roots lies in interval 0 and 1. Now moving to the step 2, we set the convergence parameter epsilon. Epsilon is equals to 1 by 2 into 10 power minus 3 is equals to 0.0005. This is our convergence point. Now step 3. In step 3, we select x0 and x1 in the interval by our own choice. We have this interval. We will select 2 points x0 and x1 in this interval. Now let x0 is equals to 0.1 and x1 is equals to 0.5. We have taken x0 is equals to 0.1 and x1 is equals to 0.5. Now moving towards step 4. Now using secant formula, which is xn plus 1 is equals to xn minus 1 function at xn minus xn f of xn minus 1 divided by function at xn minus function at xn minus 1, where n is equals to 1, 2, up to so on. Now x2, putting n is equals to 1, x2 is equals to x0 function at x1 minus x1 function at x0 divided by function at x1 minus function at x0. Now x2 is found by x2 is equals to 0.1 function at 0.5 minus 0.5 function at 0.1 divided by function at 0.5 minus function at 0.1. Now x2 is equals to 0.1. Function at 0.5 is calculated on calculator, which is 0.625 minus 0.5. Function at 0.1 is also calculated, which is 2.501 divided by 0.625 minus 2.501. X2 is found to be 0.6333. Now, function at x2, we will check, move to step number 5. Which says if modulus of function of x2 is less than epsilon, then this will be the root of nonlinear equation. Now checking this, which gives us, putting x2 in given function, we get 0.0876. Modulus of x2, function of x2, is equals to 0.0876, which is greater than epsilon. Again, step 3. Now putting x2, xn plus 1, putting n is equals to 2, we get x3 is equals to x1 function at x2 minus x2 function at x1 divided by function at x2 minus function at x1. Now we get x3 is equals to 0.5, putting function of x2, putting x2 in function, we get 0.0875 minus 0.6333 into putting x1 in function, we get 0.625 whole divided by 0.0875 minus 0.625, which gives us x3 is equals to 0.6550. Now we check again step number 5, which is x3 is equals to 0.550. We check x3, which gives us 0.0060. Now modulus of function at x3 is equals to 0.0060, which is also greater than our convergence parameter epsilon. Now again checking for x4, x4 is equals to x2. This is again step 3. Because function at x3 is greater than epsilon, we are moving towards x4. x4 is equals to x2 into function at x3 minus x3 function at x2 divided by function at x3 minus function at x2. Now x4 is equals to 0.6333 into 0.0060 minus 0.6550 into 0.0875 divided by 0.0060 minus 0.0875. Now solving this, we get x4 is equals to 0.0875 0.6566. Now checking function add x4, which gives us 0.0001. Modulus of this is equals to mod of 0.0001, which is absolutely less than epsilon. So the root of given nonlinear equation is 0.6566, which is at x4. Thank you for watching. Please subscribe my channel. Thank you very much.